Electronics are part of our world, expanding by application to open up new opportunities for automotive, healthcare, and many other industries. But today's manufacturing techniques are not sustainable. They are energy hungry and inefficient, expensive, and have limited flexibility. The world is asking us to do better. Introducing Pulse Forge tools, a new approach to thermal processes like soldering and curing. Design with more flexibility, manufacture with fewer process steps, reduce energy use, and decarbonize the supply chain. Expand your creativity to new levels. Designers are asking for more. They need to reduce form factors, reduce weight to work on wearables and stretchables, opening new market opportunities for consumers across the world, asking us to do better. If you think sustainability and freedom of design are not possible in electronics manufacturing, think again. Think Pulse Forge.
Welcome to Insituware here at IPC Apex Expo. Delighted to be joined by Chris Fredrickson, who I think recently been promoted to president of the company. So congratulations.
Thank you.
Okay. So quite a few new developments over the last couple of years, Chris, and one of them is sitting right behind us, this SM100 smart mixer. One of the things that I think when you first came out with the Mark I handheld device to measure the integrity of solder paste, one of the issues that we thought about at the time was if somebody mixes the sample at one rate and then the next guy mixes it at a faster rate, then you're not going to get the same consistent analytics. So I'm assuming this handles that. Tell us a little bit about that journey and what features you've built into the mixer.
Yep, exactly. So that is exactly right. So what we've learned from the Mark I is really it is dependent on how each individual operator will mix the paste. You can get quite a different result. So from a lot of the input that we've had with the Mark I, we've adapted that into the solder paste smart mixer. So the premise behind this is we've taken a lot of the same measurement techniques from the Mark I and integrated it into a smart lid on the solder paste jar, which then is measuring the state of the solder paste as it's mixing in the centrifugal mixer to make sure that it'll stop at exactly the right point to give you the same mix every single time.
So does that mean you don't need the Mark I anymore? You can do it all in this one unit?
There's some benefits and trade-offs between the two. So the smart mixer is really good about giving you a very consistent mix each time. The advantage of the Mark I is it can tell you a lot more about the solder paste itself. So if you say are measuring the wrong paste, you've grabbed the wrong paste for some reason, it's mixed up, that can tell you, all right, I'm using the correct paste and it's still fit for use. Whereas the smart mixer is really all about the consistency of the mixing process.
Got it. Okay. So, the Mark I unit you've actually developed as well because it's modular. The end of it is modular. So I understand you've also got a module there for conformal coatings. Tell us how that works.
Yep, absolutely. So what we've added to the Mark I to measure the fitness of conformal coatings is we now do a dielectric measurement of the coating to make sure that it is the correct viscosity and has the correct solids content in the coating. So you can add control limits there to make sure that it's dispensed the same way each time.
Right, okay. That's super. So then around the other side of the booth here, I see we have the latest addition to your stable, which is a thickness tester for conformal coatings. I understand why thickness testers are so important in conformal coating. Maybe you can explain the theory that behind your system.
Oh, absolutely. So a lot of the existing thickness testers on the market have some downsides. So if your eddy current sensors are fairly accurate, but you have to make sure that you have a solid ground plane, you can do a cross-section test, but that's destructive. There are all these, you can use a micrometer, but you have to measure the thickness of the board beforehand or a coupon. So this addresses all of those concerns. With the thickness tester that we've developed, it's an optical technique, so it's entirely non-contact, and you can measure a coated assembly without having to measure the thickness of the board itself beforehand. So in a quick, less than a second measurement, you can get a very accurate, 2 micron accurate thickness measurement on an actual assembly, non-destructively.
So you can measure any part of the board very quickly, as long as it's got no big components next to it, I guess.
Yep. The top of the sensor has to get around 6 millimeters from the top. So as long as you're away from large components, you're good.
Right. Okay. So what's the accuracy of the thickness tester?
A 2 micron accuracy of the coating.
That's pretty good. Excellent. So one of the issues we have, of course, with conformal coatings is that the viscosity, depending on the viscosity, it can flow out at a different rate, and the coverage can vary across different components. So being able to, I guess, measure any part of the board is going to be, and very quickly and accurately, is going to be a certain advantage.
Absolutely, and if you look at our general approach towards materials quality control, we're looking to control materials at every stage in the process. So you can use the conformal coating thickness tester to measure right around a component, look at the wettability, or the conformal coating fitness for use to prevent those issues earlier in the process. Right. So I think it's very complementary to the rest of our product line.
Absolutely. Well, it's great to see how Insituware is developing over the years, and certainly you've got quite a range now of really interesting testers. So congratulations, and thank you for talking about it today.
Yeah, thank you for having me.